Okay, we continue going over some of the problems on time value money, solutions to assignment 3, and we pick up where we left off on problem number 16, where now we're going to learn how to solve for unknown interest rates. All the problems until now, we've been given an interest rate. We computed the future value of present value, or the present value of future value, or present value of an annuity, and so forth. But now, we're going to be given the complete set of cash flows and be asked to solve for what interest rate is implied by those particular cash flows. And here's the first case. At what interest rate, problem 16, at what interest rate will investment double in value in exactly 10 years? Okay, I chose 50 and 100. You can put in whatever you want. You can put 1 and 2. That's actually the easiest thing. Saves you one little algebraic step, I guess. So you put 50 in at times 0, and 10 years later it's worth 100. Clearly we have a future value and a present value. So the key to all these time value money problems where we solve for an unknown interest rate, the key is to write the appropriate time value money equation. And since we have one present value and one future value, the only equation that makes sense is the future value of present amount, or you could write present value of future amount, but it's the same equation. Plug in what you know. Future value is 100, present value is 50, 1 plus r is the unknown to the 10th. Divide both sides by 50, and you're left with 1 plus r to the 10th is equal to 2. Now we can solve this algebraically, and this is the only problem, the only type of problem we can solve for the unknown interest rate algebraically, explicitly. And that problem is when you have one present value and one future value. That's the only time you can solve for r algebraically. So what we want to do now is take the 10th root of both sides, or if you will, raise both sides to the 1/10th power. 1 plus r to the 10th to the 1/10th is simply 1 plus r. On the right hand side we'll have 2 to the 1 over 10, the 1/10th power. Now we subtract 1 from each side, and you get 0.071773. Got a little carried away there. 0.0718 would have been just fine, or 7.18%. Now in your calculator, if you want to do that algebraically, you would type 2 on the HP10, 2 gold y to the x, 10 gold 1 over x equals minus 1 equals, and you'll get that 0.0718. Now you can also do this using the 5 key approach. Start with gold clear all, put in 10 for n. Now if I put 50 in positive for the present value, I've got to put the 100 in negative as the future value. This is the amount goes into the account, this is the amount I can take out of the account. Also look at the equation. They're on opposite sides. There's nothing being subtracted or anything, it's all additive. So the future value is on one side, present value is on the other. If I put the present value in positive, I'll get a negative future value. Okay, and then press I per year last, and you'll get the same rate. Number 17, let's skip through this. You're not going to be responsible for this in this class. If you're engineering or math background, you're used to logarithms, the rule of logarithms, that problem will come easy for you. If not, there's just more important things for us to consider. Let's move to 18. You borrowed $120,000 5 years ago. You repaid the loan by making payments of $31,000 at the end of each year for 5 years. Okay, what interest rates implied by this loan? So here's my time diagram. I'm going to make the 5 years ago times 0, 120,000. That's when I borrowed 120. And then I repaid it by making payments of 31,000 each year for 5 years. Make that an annuity. So again, the key is to write the appropriate time value money expression. Now I could write this with 5 present value, future value amounts and add them together. I chose instead to use the present value of an annuity. The present value is 120,000 at times 0. The annuity payment is 31,000. 1 minus 1 over 1 plus r is the unknown to the 5th power, all that divided by r. And I got to solve that for r. Now if I gave this as a homework assignment and said, okay, solve for r on the left hand side by itself to the 1 power, with everything else on the right hand side with no other r's there, you'd never finish that assignment. It's impossible. So what we want to do, if you didn't have a financial calculator or Microsoft Excel, you'd have to start guessing. Guess a rate, plug it in. Guess a rate, plug it in. Just try to keep narrowing it down. It can take you 15, 20 minutes or so. But what I suggest doing, and this is perfectly fine, is go to your financial calculator. We'll use it as our first guess. So press gold clear all, put in 5 for n, put 120,000, hit present value. Since that's positive, I must enter the annuity as negative. Now I could make 120,000 negative and make the annuity positive. It makes no difference. They just must be different signs. Press I per year. Once you've done that, then come back and we quote cheat unquote end quote. Our first guess is 9.19%. We get that from the calculator, but plug it in. If I'm grading your work on an exam, you must plug in the rate, do it correctly. So I put in 0.0919 for R and demonstrated that it's 120,000. Therefore, we can conclude the unknown interest rate is 9.19%. Okay? 19. Sally just borrowed $28,000 to buy a new car. Her monthly payment is $540.02 for 5 years. What nominal annual interest rate is she being charged? Okay, this is similar to the last problem where we have a present value annuity, but the difference is we're on a monthly basis. So that's the only adjustment we need to make for this. The present value is of $28,000, and then I have monthly payments of $540.02 for 5 years, 60 months. And again, we want to use the present value annuity formula. It would be way too tedious to write this out as present value future amount. I'd have 60 terms. Okay, put in $28,000 for the present value, put in 540.02. Now recognize this is a monthly payment, therefore everything else is on a monthly basis. 60 is put in as a number of months, and I'm solving for a monthly R. When I use the financial calculator here in a second, since I'm putting the annuity in as a monthly payment, I'm putting in the number of payments, number of monthly payments, I'm going to get interest rate per month. So let's jump ahead. On the calculator, I'm going to put in gold clear all, 60 for N, 28,000 for the present value, 540.02, make it negative for the payment, press I per year. The calculator is going to tell me it's 0.4917. And this sometimes confuses folks thinking 49%. No, it's not 49%. It's 0.4917% per month. That's the rate you plug in. Don't forget to divide it by 100. Plug it into the formula, show that it works. Don't just write 1 plus R there, an R. Plug it in with the full numbers. You demonstrate that it works. And then, since we were asked for a nominal annual interest rate, when you're asked for a nominal rate, you simply take the monthly rate. In this case, since it's monthly times 12, it was 790, you multiply by 2. So when you take a nominal rate, you ignore the compounding effect. You simply take, in this case, the monthly rate multiplied by 12, and the annual interest rate is 5.90%. Okay, so the key to this problem is to do it on the monthly basis, get the monthly interest rate, and then annualize it. Number 20. Julie borrowed $30,000 4 years ago from a friend. We'll see what kind of friend she is here in a second. She repaid the loan by making a $10,000 payment 2 years later. So there's no payment after 1 year. You can see that in the time diagram here. She borrowed $30,000. She made a $10,000 payment 2 years later, and then $15,000 payment 2 years later, year 3 and year 4. Okay. What's the implied interest rate on this loan? Well, again, the key, as I've been saying, is to write the appropriate time value money expression. And at some interest rate, $30,000 is the present value of these future amounts. So let's just write the equation that makes $30,000 the present value of $10,000 divided by 1 plus R squared. There's nothing in year 1, so just leave that out. 15,000 over 1 plus R cubed, 15,000 over 1 plus R to the 4th. And we need to solve that for R. And again, it's a trial and error solution. You'll spend the rest of your life trying to get R to the 1 power by itself on the left-hand side with no other R's on the right-hand side. It's impossible. So we go to the calculator. I'll demonstrate that last. We'll go through the steps on the next page in a second, but those steps will tell you it's 9.736%. Divide that by 100, plug it in, show that it works. Again, don't put 1 plus R there. Put in the actual rate as a decimal and conclude then the interest rate is 9.736%. How did I get that? Well, we're going to use a function we've not really talked about yet. We use the gold IRR per year. Get to that in a second. We're going to use the C S of J key since we have uneven cash flows. Start with gold clear all, and you must do this. You must do gold clear all. Now you always must enter year 0 by itself, and we actually do have a year 0 here. It's 30,000. Make it negative. It's the amount we borrow. Make it negative. And then enter the next cash flows, the inflows. Well, in year 1, there's no cash flow, so you must tell it 0 CS of J, 10,000 CS of J. Now I could do 15,000 CS of J, 15,000 CS of J, or I could do 15,000 CS of J, CS of J. But I want to show you a better way to do it for future problems. That is, type in the 15,000 CS of J and then just tell it how many you have. 2 gold N sub J. It's not saving any time in this problem, but in future problems it could. If there were 7 of them, then you'd want to do 15,000 CS a day, 7 gold ounces a day. It can be a real time saver. Also saves your storage registers on your calculator. Okay, and then you press gold IRR per year. It's in the second row from the top over towards the right. It stands for internal rate of return, something we do in capital budgeting, but we'll get there later, not in this section. But let's go ahead and use the functions. That's so powerful. Just treat it like an I per year, but it's gold, the salmon colored key, which I call gold, IRR per year, and we'll get that 9.736%. Okay? All right, this ends the second video of these solutions, and we